Hey everyone, it's Mrs. Cook. We are in Geometry section 4.4 and we are going to be talking today about how to prove two triangles are congruent, but this time we're using angle side angle and angle angle side. So I have three proofs for you that I want to get through in this video. The first thing I'd like you to do is just pause the video real quick and write down all of the givens in each of the three proofs on the front side of today's notes. So go ahead and do that, pause it, and write down all of the givens. Okay, now that we have the givens written down, I am going to mark up what those givens tell me, and then I can make statements about those. So the first given is that CX is parallel to GM. Now it does help me to highlight in some instances, so I'm going to do that here. If I have CX here parallel to GM here, I can see that I have a transversal that connects those right here at CM. Now if I connect these this transversal, then I notice that I get this Z shape. This Z shape reminds me of these alternate interior angles right here and right here. So I know if parallel lines, then these alternate interior angles are congruent. Remember when we were driving the rovers and we had to have the rover go forward, pull backward, and then go forward at that same angle. Those were alternate interior angles. So in step number 2, I'm going to say that angle GMC is congruent to angle XCM. And the reason for that is if I have parallel lines, which I did have parallel lines, then I have those alternate interior angles congruent. And I'm pretty excited about this because so far, if I'm trying to prove these triangles congruent, then I already have a pair of angles congruent. And if you want to keep tabs kind of on the side, you certainly can. This is optional. But I could say, oh look, I already have a pair of angles congruent. So I put a little A there. Now, let's see what else we were given. We were given angle G congruent to angle X. So if I'm looking at angle G, that's this angle up top. And then this angle X, that's this angle on the bottom. Oh, they just gave that to me. So that was another pair of angles. Now I need something else. And remember, when we're looking at the diagram, the things that we're looking for in all of these proofs that aren't going to be given to us will be vertical angles. So look for those. And the other thing that we're going to be looking for is the reflexive property. So we have to be really good about looking for these things. In this case, I can see the reflexive property is at work because CM, that segment, is in both triangles. So I definitely want to make a step that says that CM is congruent to CM. And I do that, again, because it's a segment that's in both triangles. Now, when I say that that's the reflexive property, I can come over here and put some tick marks on it, and all of a sudden, I have another pair of sides congruent. So I have two pairs of angles and a pair of sides congruent. Now don't say that my triangles are congruent by angle, angle, side because I have this picture or because I have it in this order, but look at the picture. And the picture is why my triangles are congruent by angle, angle, side. Notice this side here, CM, is not the included side. In order to be the included side, it would have had to have been this side that connects the blue angle to the right angle. So it's not angle side angle like yesterday. Instead, it's angle angle side today. So I'm going to wrap this up. Step number 4, I want to prove that these triangles are congruent. So I'll say triangle CGM is congruent to triangle CXM. And the reason was because of angle angle side. Okay, let's take a look at the second proof. Again, hopefully you already have those givens written. So in this one, I'm also given parallel lines. And again, for me, a really good habit to get into is to highlight those parallel lines. So this time they're giving me this segment, IO, is parallel to the segment UE. So I highlight those. And then I look for a transversal that connects those. And I can see that this segment here, AU, is a segment that connects or crosses these parallel lines. Oh, I see some green angles in my triangle. And so I can say that this angle here is congruent to this angle. Do you know what they're called? If you don't know what they're called, does it help you right now to extend and kind of see what our picture was from an earlier chapter, these two right angles are indeed corresponding angles. So I'm going to say in step number 2 that, oh, let me switch to red. Green's kind of hard to see. Okay, in step number 2, I'm going to say that angle AIO, that's this angle here, AIO, is congruent to angle IUE. IUE. You could also call that angle AUE if you wanted to. And so those are congruent because if parallel lines, then corresponding angles are congruent. All right, I have a pair of angles. Again, you can totally take note on the side, kind of keep track of what we have so far. Now, I have angle O congruent to angle E also given to me. That's a pair of angles. So I can put an A there, and I can put in those blue tick marks there that match. I was also given IO congruent to UE. So I can draw some tick marks on these segments, and I notice, oh, that's a pair of sides. So, what do we have? Well, do we have angle, side, angle, or do we have angle, angle, side? The only way to know is not by the order that it's written in the proof, but to look at the picture. And in this case, this side is the included side. It's in between these two angles. So I'm going to say in step 3, just what they wanted me to say, that these triangles are congruent. Triangle AIO is congruent to triangle IUE, and that was because of angle, side, angle. The side is included in between the two angles. Okay, last one. So we wrote down the givens. They gave me that R is the midpoint of QS. So if I look at the picture, R is the midpoint. Do you know what midpoint means? Hopefully you just said that it cuts QS in half. It is going to bisect segment QS. So I am going to say that QR is for sure congruent to RS. That's because I was given R as the midpoint. So I'll say QR is congruent to RS. Now the reason why I'm going to say that is because if I have a midpoint, MDPT, sorry, this is a new tablet, so my handwriting's awful, I apologize. If I have a midpoint, then I have two congruent segments. I believe in the math lab, though, it doesn't say that. It'll just say definition of a midpoint. So I'll take either one. Okay, I have a pair of sides, so let me put a little S here just so I can keep track of what I'm given. Also here I was given angle QRP congruent to angle SRT. So QRP congruent to SRT. That's this angle here and this angle here. Oh, that's a pair of angles, so I'll put an angle, an A for angle there. But I need something else. And when I look at this picture, there is no reflexive property, no side that's in both of the triangles. There are no vertical angles. I don't see that X shape that I always look for vertical angles. So I better look at the next given. They gave me the fact that PQ is perpendicular to QR. Do you know what perpendicular does? It makes right angles. So I am going to say in step number 3 here that angle Q is a right angle. But actually, if I take it a step further, TS is also perpendicular to SR. So why don't I just say all at once that angle Q and angle S are right angles? You can do this in separate steps or together. Angle Q and angle S are right angles. Again, the reason why I knew that was because when I'm looking at this picture, I had that perpendicularity. So I knew that those were right angles. If you want to put it in 2 steps, you can. So if perpendicular, then right angles. I believe that Math Lab is just going to say definition of perpendicular. Okay, well, what do we know about right angles? Look at, they have the same tick marks, so I know that they are congruent. So in step number 4, I can then say that angle Q is congruent to angle S because right angles are congruent. Right angles are congruent. Remember, this is my reason side, so I know that all right angles are congruent. Oh, I just got another pair of angles, so I'm going to put a little A here. And now I look at the picture. So I know that the order says ASA, but this one also could be AAS. So I have to look at the picture to see which of the two choices today it is. And when I look at the picture, the side is in between the two angles. So in step number 5, then, I'm going to wrap it up with what they wanted in step number 5 to say the triangles are congruent. QRP is congruent to SRT, and that is because of angle, side angle. We are going to practice many more proofs in the coming days before a test, but go ahead and rewind this video if at any point you were confused, and make sure you ask your teammates for help as well. Have a good rest of your day.